And here now, can you see the screen? Unmute your mic.
That means what?
You can see the screen.
Yes, sir.
Okay. So this question, is it clear? Projectile fired 45 degrees with horizontal elevation angle at projectile highest point. So you understood the question?
No, sir. What do you mean by elevation?
Yeah.
Above the x-axis.
So basically, see, this is the projectile motion, right?
Yes, sir.
Okay. So at the highest point, you are at the ground. So look at the object at the highest point. You have to lift your head, no? So this angle is called elevation. So if you want to see something at the same level as the ground level, elevation is 0. Something which you can see straight above your head, the elevation is 90 degrees. Okay.
Sir, your voice is too low, sir.
So which one are you using? Mobile or this one? Laptop?
Mobile only, sir, but I'm.
Something is going on in your background.
Sir, guys, sir. Volume. Yes, sir.
Your TV is on or what?
TV volume.
Last time this close. Reduce the volume or shut it down, right? You should ask for a separate study room. So if your mic is not on, how will I understand whether you're understanding or not?
Now, fine, sir.
So who is watching TV?
My parents from hall that mic is coming, sir.
You don't have a separate study room?
I'm in room only, sir, but the door is open.
Okay, you could close the door then. Or ask them to reduce the volume or switch off the TV. If you're studying, they also have to study.
Now, is that fine, sir?
Yeah, it's okay now. So so you understood the concept of elevation. Okay, this is not a perfectly good language, but it's okay. 2011 they have given it. So the elevation means, see, something, a person is standing on the ground. So something on the ground level, say a car coming on the road, you don't have to lift your head. Okay. But something, aircraft is flying on the sky. You have to lift your head, right?
Yes, sir. Yes, sir.
So how much degree you have to lift? That is elevation. Okay.
Oh, okay.
Okay. So something that's there right above your head, say sometimes moon will be straight above your head, right? Or sun at the noon time, it will be straight above the head, right? So that time the elevation is 90 degrees.
Yes, sir.
Okay, sun in the morning or sun during sunset, it will be 0 degrees, almost 0 degrees. So here projectile is going like this. So at the highest point, from the point where you have launched it, to look at it, you have to tilt your head a little bit. That angle is alpha. Okay, so that will be by this distance is how much? Maximum height. And what about this distance?
Half of the range.
So this is the elevation. Tan of that angle is this one. So you have to use the formula for h and range. So you remember the formula, right?
Yes, sir.
So if you remember that formula, you have to use it in this thing, and then it will become tan alpha will become half. So from this, alpha is tan inverse. Is it okay?
Okay, sir.
You can revise it later. Okay, and this question also you are asked. This is clear, or I have to explain now?
No, sir. It's clear now.
So the horizontal component of the speed will be constant throughout the path. Only the vertical component will be maximum here. It will keep on decreasing, it will become 0, and then it will keep on increasing and have the same value as this one. The direction will be different. Okay, so this is clear, no?
Yes, sir.
Okay. So the ones which you have sent right now, I will look at it later, and then I will send you the thing. And 1D problem. This thing I sent you a snap. Last time I solved it by energy conservation. Yeah, this energy conservation method is clear, no?
Yes, sir.
Okay, that I solved last time. And whenever energy conservation method is there, that usually be the easiest one. Okay, but just for sake of completeness, this you understood?
No, sir. Can you just
See,
explain?
initially the thing is dropped from a height. It travels a distance of 5 meters, right?
Yes, sir.
Okay. And after bouncing back, if it is completely elastic condition, it will bounce back with the same velocity. Okay, when it bounces back with the same velocity, it will reach the same height. But if it's not elastic, it will lose some energy because of heat or something. Okay, so when it loses some energy, kinetic energy will be lost. So the returning speed will be different, say u2. Okay, because of that, it will reach a lesser height.
Yes, sir.
Okay, so for this motion, you have to use s equal to ut plus half a d square because u is 0. So this term will go, and I'm taking upward direction as positive. This is a 1D problem.
Yes, sir.
Okay, and if this is positive means the displacement is minus 5. You understand negative sign?
Yes, sir.
Okay, and ut is 0, so half g is minus 10, t1 square. So you get t1 as 1. Is this okay?
Yes, sir.
So from this v1 is gt1 because u is 0. Okay.
Yes, sir.
For the second part, initial velocity will be something, but the topmost velocity will be 0. Okay, so you can, instead of using ut plus half a t square, you have to use vt minus half a t square. So that's why it's important to have both the formulas in mind. And once you know this thing, once you put vt, it will be a negative quantity because s is between, s will be greater than ut but less than vt. I explained in the very first lecture. You remember? So initially the velocity is u, final velocity is v. So if the full distance is traveling with this velocity u, then the distance got to be less, right?
So,
Then you getting the idea?
so can you please explain that expression is written in rows collecting collected? Yes, equal to ut minus.
Okay, hold on. So this, see this formula, if you put instead of v, if you put v equal to u plus a, I'll use the pen. We have this relation, right? V equal to u plus ad. So from this we get u as v minus ad. Is that correct?
Yes, sir.
So in this formula, ut plus half ad square, you eliminate u, you put as v minus at, so it will become vt minus a t square, right? Minus at square. Minus at square and half at square can combine to give minus half at square.
Okay, sir. Okay.
Okay. But to understand this thing, whenever there is a formula, you have to understand that only then it will become easier to remember it. See, I'm moving from point A to point B. The initial velocity is u, the final velocity is v. Okay, but instead of that, if I move the whole distance by a velocity u and say v is greater than u, if you move the whole distance by u velocity, then the distance covered will be less than the actual distance, right? Or the actual distance covered is greater than ut. Ut is the distance covered or the displacement when the full path I'm traveling the same velocity u. say U is say 2 meters per second and V is 5 meters per second. So in between 2.1, 2.2, 3, 4, 5, the velocity keep on increasing. If I do that way, I'll cover some distance, but instead I'll travel with 2 meters per second, 2 meters per second, 2 meters per second, 2 meters per second throughout. That way I'll cover only lesser distance in the same amount of time. Is that clear?
Yes, sir. Yes, sir.
So this is always greater than ut, and the amount by which it's greater is half at square.
Yes, sir.
Okay,
Yes, sir.
just for removing the form I'm saying. But instead, if I assume I'm traveling with 5, 5, 5, 5, 5, I'll travel much higher distance, no?
Yes, sir.
So this is less than Vt. By how much it is less is minus half at square.
Okay. Okay.
If you are remembering the formula I'm saying, if you're understanding the formula, it's remembering it's a little bit easier. So AC to dV plus half at square, you remember. So from that, I can write in terms of Vt minus half at square. But since it should be less than Vt, it is minus here. And since it should be greater than Ut, it is plus half at square. Okay.
Yes, sir. Got it.
Okay. And now V is 0. Okay, so this term will go. So that is the advantage of using this formula in terms of Vt. So, and S is 1 plus 1.8. It is plus here because upward direction is positive. Okay.
Yes, sir.
And half A is again say minus 10. From that I get T2 square as this one. Okay.
Yes, sir.
And U is GT2. You get from this one only, but you have to put V equal to 0. And G is minus G.
Yes, sir.
Okay, T2 is the time to go from here to here. So from this T2 I got from here, that value. So you have to find the ratio of U2 by V1, by how much the velocity is decreasing, the factor of which. So that is T2 by T1. T1 is 1. So T2 is square root of 1.8 by 5, that is same as 18 by 50. So that is 9 by 25. 2 will cancel.
3 by 7.
So 3 by 5. Is it clear?
Yes, sir.
Okay. But this is easier. Half m
Yes, sir.
v1 square per mgh, and then in the second case it's half m v2 square. U is initial velocity, mgh2. If I divide this thing, I'll get 5 by 1.8. So always energy conservation method will be easier to solve.
Okay.
Okay, the snap situation, I have to look at it. So I'll do that later. So we will today's topic.
Thank you.
So all the questions you have sent is 2D and 1D, right?
1D only, sir.
Okay. So this today we'll do this one, error analysis, Vernier Caliper and screw gauge. So
We haven't seen that relative velocity now, sir. That umbrella, rainwater potential.
oh yeah.
Those things.
Okay, I'll do it. The basic idea is this one only. Velocity of A with respect to B is VA minus VB. The only thing is you have to put a vector. Okay, because it's a 2D motion. 1D motion you don't have to put a vector sign because the direction will be taken care by the sign, positive sign and negative sign.
Okay.
Okay, so I'll do that next time. Error in measurement, direct quantities. Okay, so what's a common ruler? The one you use. This is a common ruler. Okay, so this is what unit?
Centimeter.
The bottom one is inch. We will just leave it. Inch is not required. Just look at the centimeter and how much is one division?
10 millimeter.
No. Between 13 and 14, 10. But each division is how much? One division is this much. This much only. That is 1 mm.
Okay.
Between 9 centimeters. Between 1 centimeter is divided into 10 parts. Is it clear?
Yes, sir. Yes, sir.
Okay, I have magnified it here. So 1 centimeter is divided into 10 parts. So each division, okay, it's 1 mm. So with this scale, what is the accuracy of my measurement?
Millimeter.
What is the minimum distance I can measure from this one?
Millimeter. 1 millimeter.
1 mm.
Ah.
Okay. So if the distance is 5 and 5.1, I can say it whether it's 5 or 5.1. Okay. So the accuracy is 1 mm.
Yes, sir.
Okay. So what is the minimum distance can be measured? That's 1 mm. So consider of 10.2 centimeters. What is the error with which it can be measured using common ruler? So what will be the error of measuring 10.2 centimeters using this common ruler?
It could be 10.3 or 10.1, sir.
No, it's exactly 10.2, right? So it will show me at the coincidence with the second division. So error is 0. See, I can measure exactly 10.2. What is the problem? There is divisions are there. No? See, if it is 10.25, then you can say there will be some error. What is 10.2 means is exactly coincident with the second division here, no?
Yes, sir. That will be human error.
Okay, so there is 0 error. But suppose I say there is a length of 10.23 centimeters and using a common ruler, what is the error in this case?
I can't measure 0.01 millimeter using
So I can say it's greater than 10.2 and less than 10.3. Okay, so the error will be 0.03 centimeters. Is that clear? Worst case I'm saying.
Yes, sir.
So that is 0.3 mm. So fraction of mm I cannot measure. Okay, because the division here is 1 mm. So 0.3 is fraction of mm. So I cannot measure this distance. So error will be of this value. But if I'm given two scales, okay, one with 1 mm divisions and this is 1 mm division. So this is an example of a 1 mm division scale. Okay, another scale with 0.9 mm divisions. So this division is a little bit smaller than the 1 mm division. So what is the procedure to measure 10.2 centimeters without any error? Can you think of a method? I have to measure 10. Okay, so see 10.23 will look like this, right? This is 0, so 10.3 is somewhere here. So up to 10.2 I can measure accurately using the 1 mm division. Is that right?
Yes, sir.
Okay, and after that, so this is the delta distance I have to add. So the actual measurement length is 10.2 plus this delta. Okay, so to find this delta, I have two scales. 1 mm scale is there. 1 mm scale means divisions of 1 mm. The distance between two divisions is 1 mm. Similarly, I have a second scale of divisions 0.9 mm. So distance between two divisions is 0.9 mm. So suppose I find a common point from using this 0.9 mm scale. If I'm able to measure distance up to this one, say L2, and using this 1 mm scale, I'm able to measure distance from this common point to this point. Then delta in terms of L1 and L2 is what? L1 minus L2, right? So if these two scales, if I'm able to do this sort of a thing where I can find a common point, from this common point I can find this distance and this distance, then I can find delta accurately. Okay, so for this thing to happen, say let the number of divisions by which this point is far away from this point be n. Okay, so this distance will be n into 0.9 mm. Okay, and let the number of divisions of this scale will also be n for from here to here. So that will be n into 1 mm. Okay, so the number of divisions that will be is 3. So it will be like this. Here will be 3 divisions. 1, 2, and 3. And this one division is 0.1. Here also there will be 3 divisions. And this is the third division. This is second, and the third division will be here. Okay, and each division is 1 mm. So if I'm able to do this sort of thing, so I know this delta is n times difference between 1 mm and 0.8 mm. So if you are getting the idea, say you have a 0.9 mm scale. From this point, 3 divisions will come here, and with 1 mm scale from this point I'll come here. So the difference between these two is 0.3 mm, right? So that is this much distance. So after 3 divisions, these two scales, the divisions will coincide. Is it clear? Okay, I have given another example.
Okay.
See, there are two people walking. Person A, and his step size is, say this is one step size, say, and his step size is 1 meter. Okay, there's another person B whose step size is 0.9 meter. Okay, and he starts a little bit earlier. 1, 2, 3, 4. So it's possible for them to reach the same point after 4 steps. Okay, and for it to happen, this guy with the bigger step should start a little bit behind.
Yes, sir.
Okay, so this initial difference is 4 times 1 minus 4 times 0.9. So that is 0.4 meter. So this guy should start behind this guy by 0.4 meter. Okay, so similar things happening here. I have two scales. One scale, the divisions are 0.9, other scale, the division is 0.1, and both have to catch up at some distance. Okay, so this catching up distance will happen at some place. From there, I can measure this delta as, and both are taking equal number of steps.
Okay.
Okay, so from this, I'll explain this one, Vernier Calipers. So this is Vernier Calipers, which is the main scale here.
The one
This one. Okay, and where is the Vernier scale? This one.
Yes, sir.
From here to here. Okay, and this one is main scale only. So what is one division of this main scale? 1 mm. This is same as common ruler. Vernier caliper you have read in school, right? In the lab.
No, sir. I don't know.
Okay, Vernier caliper you used not Akash more they were taught you, no?
Yes, sir. We just read the formula alone.
Yeah. That's what you have to understand the formula. That's why I'm telling all the stories and all. Otherwise, I just tell the formula and ask you to solve. Okay, so this is the scale, same as common ruler. So one division is 1 mm, and have a finer scale where one division is 0.9 mm. Okay, so here what is the current reading now? How much is this distance? This distance is how much? It's greater than 2, right? See, this is 0 of the vernier. This point, this one is 0 of the vernier scale. The first division.
Okay, yes, sir.
Okay, so what is main scale reading here? And this is the rod I'm measuring the length. Which is main scale reading here? You have to see this one. 0 is coming after 2, no? So just before this 0, what is the reading? 2. Is that correct?
After that 0.
Yeah. 0 is after 2. It's a little bit off after 2. So main scale reading is, so the length of the rod is actually greater than 2 centimeters. It's equal to 2 centimeters plus delta.
Yes, sir.
Okay, the delta is the one I have to find using this vernier thing. So where is the vernier scale coinciding here?
2.1.
No. This fifth division is coinciding. Okay? This is the division that is coinciding. Just look properly. The fifth division. This is the one that's coinciding, right? 4 is also a little bit off. 3 is also a little bit off. 2 is also a little bit off. Everything is off. The first division that is coinciding is 5.
2.5.
Don't say 2.5 at all. Number of divisions the thing it has traveled for it to coincide is 5. See here, I have the two people have taken 4 steps for them to meet, right? Here the vernier scale and the main scale have taken 5 divisions for it to coincide.
Okay.
After first division, they have not coincided. Second division, they have not coincided. Third, they have not coincided. Fourth also, they have not coincided. But the fifth division, they have coincided.
Yes, sir.
Okay, so 5 steps there. It's so this corresponds to then delta will be 5 times 0.1 mm. That is happening, right? If you take n steps to coincide, so this L1 will be n times the bigger step. Okay, and this L2 will be n times the smaller step. So to subtract these two, so it will be n, which is common. Both are taking equal number of steps, and the difference between the divisions of the two of them. So that will be 0.1 mm.
Yes, sir.
So it is 5 times 0.1 mm. So it is 0.5 mm. So it is 2.5 mm. So actually this 0 is exactly between 2 and 2.1 centimeters. And visually also it's like that, but you can measure it accurately. Usually if you are looking properly, then you can say it's in the middle. But instead of that, you can just see where the divisions are coinciding. So from there, I have to measure backwards.
Yes, sir.
Okay, so even if the 0 of this vernier is coinciding close to this 2.1, main scale reading is still 2 only. So the delta will be more here, and instead of 5th step coinciding, the 9th step will coincide with the 9th step of this main scale.
Okay.
Okay, you got it now. So you don't have to choose which one is closer. So instead of 2.5 here, suppose it was the length of the rod is 2.9 centimeters, then actually the 0 of this vernier will be close to, actually it's 2.0, right? So this length is, 2.05, not 2.5. 2.0 is less than 2.1, 2.05. So instead of that, if it is 2.09, the 0 will be closer to the first division, but still the main scale reading will be 2 centimeters only. Only the delta will be more, and the more delta will correspond to the more number of steps taken before coinciding.
Okay.
Okay, so this is the formula. Measured length equal to the main scale reading plus the coinciding division into the least count. So here, what is the accuracy with which you can measure? 0.1 mm, because number of steps is whatever you can say accurately. The accuracy is decided by the difference of these two divisions, right?
Yes, sir.
Okay, so either it can be third division or fourth division. So the accuracy is 3 or 4, and difference is 0.1. So the accuracy with which you can measure is 0.1 mm. The accuracy of main scale is 1 mm, and the accuracy of vernier scale alone is 0.9 mm. But the combination will give an accuracy of 0.1 mm. Getting it? So main scale accuracy is 0.9 mm. Vernier scale, if you just take the vernier alone, okay, it's 0.9 mm. But the accuracy of vernier calipers, which is combination of these two scales, is 0.1 mm.
Okay.
That is why least count of vernier is defined like this. Got it, no?
Okay.
Okay. So you always have to understand the formula, because in the exam they might change the, or instead of 10 divisions of, here 10 divisions of vernier will be equal to 9 divisions of main scale. That is why this thing is 0.9 mm. Okay, so they can change a little bit, like instead of saying 10 this thing, they can make it 11. So if you know the basic idea, then you can solve it a little bit easier. Okay. So after that, in addition to that, there can be some zero error. Zero error means suppose when these two jaws are coinciding, what should be the this zero base vernier should coincide with zero base mean scale. If there is no zero error, right? When these two jaws are closed, okay, fully closed without any gap, then the zero base vernier should coincide with zero the mean scale. Is that correct?
Yes, sir.
No, see, this jaw is for holding that object, right? If there is no object, you can move it fully and close it, no? Yes? Understood?
If the object is too small,
No, not too small. There is no object.
uh,
There is no object. I'm just closing this one fully. So when I close the thing fully, the zero of this vernier should coincide here, should come here, exactly. Right?
yes,
Okay.
okay.
If there is no error, but if it doesn't come back fully, then suppose it comes back only up to this one. Okay, so for zero, when it's actually zero, it is showing some two divisions, right? That is 0.2 mm. So that 0.2 mm is zero error.
Okay.
So when it is actually zero, that is when the two jaws are touching each other, the zero of this vernier is not coinciding here, but it is coinciding here, say the second division. So that means that the zero error is 0.2 mm. Okay, so when the actual thing is saying 1 centimeter, then what will be the measured length? It will be 1 centimeter plus 0.2 mm. Is that correct? When there is zero, when there is nothing is there, when these two jaws are touching each other, it is showing a zero reading of 0.2 mm. That is zero error. But the actual rod is say 1 centimeter, the measured length will come out to be 1 centimeter plus 0.2 mm. Because without nothing being there, it's showing 0.2 mm. When the rod is of length 1 centimeter, it will show 1 centimeter plus this additional value, which is not correct, which is an error. But since I know it's a known error, I'll subtract it to get the correct value. Okay, so so whatever is the measured value, I have to subtract 0.2 mm to get the correct value of 1 centimeter. So zero error when the actual length is zero, that is when the two jaws are touching each other, there is a non-zero reading. Okay, if it's a 100% good Vernier calipers, this will not be there. It will be zero only, but there is a non-zero reading. That reading is called zero error. Okay, so non-zero reading is that zero ZE, zero error. So the correct reading is measured reading minus is important, minus zero error. Okay, because without nothing being there, if it's showing 0.5 mm, so whatever distance I'm measuring, I have to subtract that 0.5 mm from the measured value. So positive error is getting subtracted. Okay, similarly the negative error, suppose when the two jaws are closed, okay, the zero of this thing is coming here. Okay, and say this distance is say 3 mm, 0.3 mm. So when I place an object of 0.3 mm, the measured length will be zero. So I have to add this zero error here.
Yes, sir.
Okay. So this negative zero means the value will be negative when nothing is there. So negative zero error will get added.
Yes, sir.
Okay. Similarly, screw gauge. So when the two object will be kept here. So when these two jaws are when these two things are closed, it should show zero. So what are the two scales here? One is this one. Okay. That you can call it pitch scale. Another is the circular scale. Okay, you can see the circular scale.
Yes, sir.
So can you guess this pitch scale? What is one division? How much is this one division?
I don't know, sir.
From here to here, 1 mm. It is same as a common ruler and main scale. The main scale of this vernier calipers and this pitch scale of this thing, and also the common ruler, everything is 1 mm only. Okay, and after that, to get a fraction of 1 mm, we should have to use the second scale. Okay, so here when this what do we recall this thing, when you rotate this thing fully by 360 degrees, 360 degrees correspond to 1 full revolution. You know that, right? 1 full rotation.
Yes.
Okay, so when this thing rotates 1 fully, or you have to loosen it for the thing to move outwards. So to make it move, okay, I have to rotate in the anti-clockwise direction. So when I rotate in the anti-clockwise direction, this thing will come out like this. Okay, so when I rotate with 360 degrees, how much will it come out? It will come out by 1 division. Okay, that's how it is designed. Okay, and this 1 division, this distance is called pitch. You have seen a screw, right?
Oh.
It will be like this. Okay, on the screw there will be threads, right? Okay. Yes. There will be the threads on the screw. And what is the distance between two threads? And suppose I rotate this screw anti-clockwise by 1 rotation, how much will the screw come out? Okay, that is the basic idea of screw. So whenever I rotate the screw by 1 rotation, the pitch, the screw will move out by 1 thread division, the distance between 2 consecutive threads. And this distance between 2 threads is called pitch of a thread.
Okay.
You know helix?
Yes, sir.
You know circle, right? Circular ring.
Yes, sir.
Okay, you cut the circular ring. Just take one circular ring, you cut it, and then you stretch it out like a spring. Okay, so how much distance it moves vertically? Say the circular ring is on the table. I cut the ring and pull it vertically up. So the distance by which I can pull up is I can pull how much I want, right? So that distance is called pitch. So one complete rotation of that going along the ring, how much vertical distance I'm traveling. So same thing is happening here. Here there is no circle, so it's like a spiral. So from one thread to another thread, whatever is the distance, that much is the distance that will come out when I'm rotating the screw by 1 rotation. So this thing is basically a screw here. It's being covered with some covering, but inside there is a screw. So when this rotate the screw by 1 rotation, the screw will come out by 1 pitch. So, and 1 pitch is 1 mm here. So this is a screw, the outer cover is a screw. So that will come out, and the amount by which it comes out is 1 mm. So 1 full rotation corresponds to 1 pitch, and 1 pitch is usually 1 mm. So, and this circular scale, it's divided as 100 divisions. Okay, so when this thing is rotated by 100 divisions, that corresponds to 1 full rotation of this the outer sleeve, or you can say the screw. Okay, but suppose there are 100 divisions. Suppose I rotate this screw by 50 divisions, then how much will it come out? So this thing I'm rotating by 1 instead of 1. So it will come out by half pitch, right? So it will come out by 0.5 mm, which is 1 mm. If I rotate by 360 degrees or 100 divisions, it will come out by 1 mm. Suppose I rotate by 50 divisions, it will come out by 0.5 mm. Is that clear?
Yes.
So yes, 25 divisions, if I rotate out, it will come out by how much?
0.25 mm.
1/4 of the pitch.
Yes,
Yeah.
sir.
Similarly, if I rotate by 1 division, how much will it come out?
0.01 mm.
So basically 1 division divided by total number of divisions into the pitch, right? And pitch is 1 mm.
Okay.
So 0.001 mm. Is that right?
Yes, sir.
So how much accuracy with which I can measure with this screw gauge?
The 0.01 mm.
No, total number of divisions is 100, no, on the circular scale. So I'm rotating by just one division. So the amount, see, if I rotate by 50 divisions, it will be 50 by 100 into pitch, right?
Yes, sir. That will be 0.01 mm only. So we have written 0.001.
Okay, fine. All right. So what is the accuracy of this screw gauge?
0.01 mm.
Now, so accuracy of Vernier calipers is how much?
0.1 mm.
So now we understand why the screw gauge is more accurate, right? So can I
Yes, sir.
make this screw gauge 0.001 mm accurate?
How could that be possible, sir?
Just think, how is it possible? Suppose the number of circular scale divisions, I make it 1000 instead of 100.
Yes, sir. Yes.
Okay, so in the exam, instead of making 100, they can make it 200 also, 200 divisions. Okay, so in that case, the accuracy will be 1 by 200 into pitch. Okay, so it will be 0.005 mm. Actually, the concept of screw gauge is simpler than Vernier scale, because whatever is the pitch here, that pitch is corresponding to whatever is the total number of divisions of the circular scale. So the minimum I can measure is one division of the circular scale. So one division of the circular scale will correspond to 1 divided by the total number of divisions into the pitch. Got it?
Mhm.
Okay, so that's what the least count here is pitch divided by number of circular scale divisions. Is that clear?
Yes, sir.
Okay, so I measured like this main scale reading, okay, plus circular scale reading into the least count. Okay.
1 minute, sir.
See here, what is the reading here? 5, 5.1, 5.2, 5.3, right? 5.3 plus something. Is that clear?
Yes, sir.
5.1, 5.2, 5.3 is the last thing visible. So 5.3 plus something. That something is 98 divisions. Right? This is 0 and 10 is above. Okay, so 90 is here. 99. Okay, it's almost 98, between 98 and 99. So we can either take 98 or 99. So 5.4 plus 98 by 100 into pitch. Is that clear?
1 second, please. Repeat it. Sir, can you repeat it again?
See, here something is kept here, the rod is kept here. So I have to measure the length of this rod as measured with a screw gauge. So it is 5.4 centimeters, right? Sorry, mm.
Yes, sir.
No, 5.4 mm. 1, 2, 3, 5.3 plus something. So it's 5.3 mm plus something. Okay, that
Yes.
something is 98 divisions, because 98 divisions of this circular scale is coinciding with this line. This is the reference
Yes,
line. Okay.
5.3 plus 1 pitch by 98.
Not one pitch. One pitch is full this thing. It's only 98. So 98 by 100 into the pitch. So this is so the length will be 5.3 mm plus delta, and this delta is 98 divisions of the circular scale divided by the total divisions 100 into the pitch, which is 1 mm. Okay, so it's 0.98. So it's almost close to 5.4. 5.399.
Yes, sir.
Okay. So here also there can be zero error, in the sense like when the thing is completely moved here, when I completely move this thing to this point, if the screw gauge is perfect, then the zero of this circular division should coincide with this baseline here, and it come up to here, and the zero of the circular scale should coincide with this reference line. In that case, there is no zero error. But if it is showing some 10 divisions or something, so for nothing being present, it is showing a reading of 10 by 100 into the pitch. Some measurement is showing. So when I play something, it will show some extra length corresponding to this one. So that should be subtracted. So here also zero reading should be subtracted. So here also I can have so this is no zero error, because zero of this thing is coincident with zero when these two are touching each other. When these two are touching each other, then that means the actual length is zero. So when the actual length is zero and this is the correct thing, so that means there is no zero error. Okay.
Yes, sir.
But if it is showing something, then it's like 2 divisions or something. So 2 divided by 100 into pitch, that is the length it is showing here when it is actually zero. So this is a positive error which should be subtracted.
Yes, sir.
Okay. Similarly here, here in this case, if I place something of a length corresponding to this one, that is around 4 divisions. So 4 by 100 into pitch. Only if I keep an object of that much this thing, it will show zero reading. So whatever is the length of the object, it will show a lesser reading corresponding to this error. So this is zero negative error, which should be added to the measured length. Is it clear?
Yes, sir.
Okay.
Yes, sir.
Right. So screw gauge concept is a little bit easier. Okay. So this is the formula, but you have to understand the formula, because in the exam they might change a little bit. Instead of saying 100 divisions, they can say make it 50, but the basic idea will remain the same. Okay, you can revise it. Okay, here there is a question. Just try. Read the question. You have pen and paper. Read the question and just try the question. Understood the question? Question is clear?
Yes, sir.
Okay. So what is the answer? So the length is diameter is greater than 5 mm or less than 5 mm. Got it?
Sir, how to calculate circular scale reading?
See, it's saying 25 divisions, no? So 25 by the number of divisions is how much? So, okay, he's straight away given the least count. So least count is what? One division of the circular scale, right? So least count will correspond to one division, number of circular scale divisions, pitch divided by number of circular scale divisions. That will be the least count. Or whatever is the circular scale reading, that will correspond to least count into circular scale divisions. See, least count is the minimum thing that you can measure, right? With the screw gauge. The minimum thing that you can measure with the screw gauge is the circular scale division. Okay, so the least count of this thing is the total number of divisions of circular scale, that is, and that is which will get divided by that much, no? One full rotation will correspond to the pitch. So I can measure 1 by number of circular. If there are 100 divisions of circular scale, I can measure 1/100th of the pitch. So least count is pitch divided by number of circular scale divisions. Is that correct? Sorry, least count is pitch divided by number of circular scale divisions.
Yes, sir.
Because the fraction of the pitch I can measure is decided by the number of circular scale divisions. So if 100 circular scale divisions are there, the minimum I can measure is pitch divided by 100. So least count is pitch divided by number of circular scale divisions. And he has straight away given the pitch. So whatever the delta corresponds to, least count is the number of circular scale divisions.
How to calculate that circular scale reading, sir?
So the diameter is 5 mm plus delta. You understand that? Okay. So the delta is 25 divisions, right? So 25 divided by 25 into 0.001. Here straight away given the least count. Okay. So 1 division of the circular scale corresponds to 0.001. So 25 divisions will corresponds to 25 into 0.001.
0.025.
Okay. So it is 5 plus 5 mm plus. He has given in centimeters. You have to be careful. So it will be 0.01 mm. So it is 0.25 mm. So 5.25 mm is screw gauge combination. And after that, I have to correct for this error. So plus 0.04 mm. See, main scale reading is 5 mm.
0.529.
Okay, so my actual diameter should be 5 mm plus something, and circular scale division is 25. So that will correspond to 25 to the least count. Okay, so least count is the fraction of the pitch. That will correspond to 1 division. So since I have 25 divisions, so it will be 25 into 0.001 mm. So that is 0.25 mm. So 5 plus 0.25 mm is the thing, and then I have to correct for the zero error. So since zero error is negative, I have to add it. So everything in terms of mm will be 0.25 and 0.05, and the first one is 5. In terms of centimeters, it is 0.529. So correct option 4. Is it clear?
Yes, sir, clear.
So least count is number of circular scale divisions, pitch divided by number of circular scale divisions. Okay, I think I mentioned it there. Okay, same thing. Least count is pitch divided by number of circular scale divisions. So this is the minimum I can measure with the screw gauge. Okay, and how to combine it? Okay, let me explain one more thing. So if you have two quantities, see, I'm measuring one quantity, and say the error in this quantity is plus or minus 3, and I'm measuring another quantity B, and the error in this measurement is say plus or minus 5. Forget about the units and all. Now I'm defining a new quantity C equal to A plus B. So how much will be the error in this C? We can call it delta C. How much will be delta C B?
A plus B plus or minus 8.
Plus or minus 8, right? Okay, so you just will take the worst case. It will be plus 3 here, plus 3 here, plus 5 here. So we will plus 8 and minus 2. Okay, minus 8. Okay. Similarly, if I have to, if I say another quantity D, which is say A into B. How much is error in B? Or actually, instead of saying it will be easier to find error in, what is the value of this one? Delta A by D. Delta A is
A by 3 by A plus 5 by B.
Okay. So actually, this quantity is also, it is not, this 3 is actually, it's not plus or minus. Okay. So this is actually percent, 5%. So the meaning of this thing is the error is, actually
3%
the
of
3 is delta A divided by E. This 5 is equal to delta B. It's a fractional error, not the exact error. It's a fractional error. It's called fractional error. No, yeah, it's fractional error. So it's going to find fractional error in D. So that will be equal to delta E by A plus delta B by B. So it is 8%. Is that clear?
Yes, sir.
Okay. And suppose I have another quantity, say E, which is A by B. So what is delta E by E?
That is also delta A by A. Delta B by B.
That's also 8%.
Yes, sir.
Is it clear?
Yes, sir.
Okay. So the way to understand is, so what you have to do is you have to take log on both the sides. So ln C equal to ln E. This you know, right? Okay.
Yes, sir.
Now we have to differentiate both the sides. So it's a partial differentiation. So ln of C is 1 by C. Everything is a variable. A, B, C are variables. So into DC, or you can put delta C also. And this is partial derivative with respect to A. So it's 1 by A dA plus 1 by C DC. Sorry, B.
So I have to differentiate the DC with respect to what, sir?
Partial. All are variables. ABC are variables. All variables. So you have to differentiate the first term with respect to C. That's why I put DC. What is the variable of integration will appear as DC. Second term I have to differentiate with respect to A. Third one I have to differentiate with T. So this is the formula you have here. That's how we got this formula. Got it?
Yes, sir.
Okay. Similarly, if it is A by B also, instead of whenever you have to take the other, you have to take either plus or minus. You have to take the worst case. So even if it's A by B, your formula will be same. Okay. Got it, no?
Yes, sir.
So this is NEET 2019. Solve this one. Got the answer?
16. Second option.
Yes. So ln x is this one. Okay. So got it, no? Suppose I have two quantities, E and its error is say plus 5 and minus 3, and B the error is actually it's percent say, and B error is say minus 2% and plus 7%. So now I define C plus B. So now what is the, how much is this percent? Can you give the answer?
A plus B into 2 plus 5, 7 also.
No, A and B I'm adding, no. So the worst case will be 5% plus 7 will be 12%, no. On the negative side will be minus 5%. See, worst case is both the errors are positive and both the errors are positive maximum. Okay, so it will be 5 plus 7, that will be the worst case error in the positive side.
Yes, sir.
And on the negative side, the worst case error will be minus 3 and then minus 2 will be minus 5. So the error need not be always equal on both negative and positive. But here in this question and all, it's both equal. Okay. Okay. Here, this 2 kilometers equal to how much? 4 options are given. So which one is the correct option? Okay, I'll just say quickly. If you don't know it, see, when they write something like 2.0 kilometers, what it means?
Sir, digits before the point is significant or not, sir?
Okay, let me give the idea. You can just see, when they give it as 2.0 kilometers, what it means, I can differentiate between 2.1 or it's 1.9. So when they give it as 2.0, it's not 2.1 or 2. So this means accuracy is 0.1 kilometer. Okay, so I can measure accuracy of 0.1 kilometers, 100 meters. Okay, so this thing I can differentiate between, since if the something has been written like 2000, then it means I can differentiate between 2001 and 2002. This thing means accuracy is 1 meter. The first one.
Yes, sir.
You can't see the pen at all. So option is not. Second one, it means I can differentiate between 2.1 and 2.2 and 1.9. And so I can make it 0.1 into 1000. So here the accuracy is 100 meters. That is same as this one. So option 2 is correct. Option 3 means I can differentiate between 0.1 and 0.2. That is 0.1 into 10 raised to 4. That is 1000 meters. Here the accuracy is 1000 meters. So this is also not true. This is also not true. First one. So the correct option is option 2. All right. So in this one, okay, the first one is simple. You know that, right? This one, just see it quickly. Radius accuracy is 2%. Okay, so then error in volume is how much? This is very simple. It will be 6%.
By 2 by 2.
Is it clear?
I forgot that one, sir.
See, volume is, what is the formula? Volume is 4 by 3.
Pi r cube.
So to get delta V by V, it will be 3 times delta R by R. Yes, no? Same thing here, the one you saw here. Whatever is the relation, the error will get added like this, no?
Yes, sir. Yes, sir. I was just differentiating that.
So error in radius is 2%, so error in volume is 6%.
Yes, sir.
The student measures the distance traversed in free fall body initially. So given time he uses. Okay, to try this one, second one.
E plus E1 plus 2 E2.
Now, first you have to get the formula. The distance is what?
S equal to half dt square.
This is the formula, right? Because u is 0. Okay, so you have to find the error in G, right? So you can bring this T on the other side. So this will give delta G by G equal to delta S by S plus 2 times delta T by T. Is that correct?
Yes, sir.
Okay, so what is the answer?
First option.
E1 plus 2 E2, right? Yes. Okay, the next one is also the voltage across a bulb is 220 volts. What is the answer for the third one?
I don't understand.
No, you have first you have to get the formula. Power equal to voltage current, right? So,
Yes, sir.
so there is an error in or whatever. There is a drop change in this power by 2.5%. So what is the percentage voltage? Okay, P into I. This is also V square by R. Is that correct?
Yes, sir.
Okay, so error in the power is given, so you have to find the error in voltage is no 2.5%, so it will be delta P by P is twice delta V by V. There is no error in resistance. Okay, so there is only error in the voltage. So this is twice, so it will be 5%. Is it clear?
Yes, sir.
Okay, basically our first thing is you have to get the formula. Only then you know how the different quantities are related. From this, you know the relation of the different errors. Okay, this is already done. Fourth one. So fourth one is similar to sixth one.
Yes, sir.
Let's not do it. It is exactly same as this sixth one. Okay. Fourth one is clear, no?
Yes, sir.
Okay. Right. So you have any questions in the concepts of 1D motion, 2D motion? Okay, 2D you have to say relative motion I have to do, no? Right, even projectile also we have not solved any much problems.
Yes, sir. Only formula different.
Okay, so projectile motion we have not solved the problem. Can you try this 22? It's actually very simple.
Not clear.
Okay, this is very trivial. You know how to do it?
Yes, sir.
So just tell me the step.
The components VI cap plus VJ cap.
Okay, to
VX
find the
I cap.
acceleration, first you have to find the velocity, right?
Yes, sir.
So Vx is dx by dt, and once you get Vx, you have to get Ax as d by dt of Vx. Okay, or you can take Ax as d square x by dt square, and Ay as d square y by dt square.
Yes, sir.
Okay, so this is simple. You can do it.
-1. Option 2. Down.
It's fine. Okay, this, did you look at this link? How many problems you have tried? Did you try any of these things?
No, sir.
Solutions are also there, but you have to look at this which only after trying. So you know how to use this website, you know? If you look at this thing, here you have topic wise, okay, 1D, 2D, universal also motion, and here you have this. In the end, they have given errors in measurements. Okay, so you can click anything and then you can practice problems from here. So tomorrow should I start? Okay, I have to do relative motion, no? Right.
Yes, sir.
So tomorrow I'll start with relative motion. After that, should I start this one universal motion? And or you
Sir,
want
we'll
the
have
problem?
more problems.
Okay.
Concept related.
Okay, the problems you have sent today.
Yes, sir.
Okay, those problems have you tried?
Which one, sir?
The one which you sent snaps just now.
Yes, sir. I tried it.
Okay, right. Okay, so tomorrow I'll do. Right. So let me take this one again. Okay, let us take simple problem. Okay, this one 6 at uppermost point, projectile of a project's velocity and acceleration are at an angle.
90 degrees.
Acceleration is downwards. Okay, and at the topmost point, vertical velocity is 0, so 90. So 6 is 2. Yes. And oops. This simple one, 7. You just tell me the method, not actually solve it. You know the method, right? How to do it?
Yes, sir. We have to integrate it acceleration.
Acceleration is known. Whenever force
Yes,
is known,
but
acceleration is known because force and acceleration are same, except for the mass.
yes, sir.
So mass is given, so force is known, acceleration is known, and to get velocity, you have to integrate it. Right. Find the angles of projection for angles of projection.
Complementary angles horizontal will be 1:1 ratio.
For angles of projections, the horizontal angles. Will it be same?
Yes, sir.
Okay. The particle. So H1 is 1 million. The particle starting from origin, moves in straight line. He is in straight line. No, this is also trivial. So I have to take tan inverse. Y is 3 by root 3. So it's 1 by root 3. Tan inverse 1 by root 3 is 30 degrees.
No, sir. √3, no, sir. Y3.
Y is, sorry, 60 degrees. So minus 4. Taking the particle mass in specific velocity of that particle center lands on the ground level. The magnitude of changing. This is also trivial.
2 MV.
45 degrees. No, 2 mv. That v is actually, see, the horizontal component momentum will not change. Only the vertical component will change. 2 mv, but that v is v by root 2. So it's mv by root 2. 10 is 4. Now 10 is 1. One and 4 are same. Sorry. See, the change in momentum is 2 mv. What you said is correct, but that v is not the total v. It's just the vy, and vy is v by root 2. So it is root 2 times mv.
Yes, sir.
Got it now?
Yes, sir.
So don't skip steps if you're not clear. You always have to write the steps. So actually and moment is a vector quantity. Okay, what is it is if it is the thing is moving in a straight line. Okay, but here it's a vector quantity, so the x component will not changing, only the y component, and y component direction is changing. So it will be 2m into velocity of the y component, which is v by root 2 because it's 45 degrees. So it will be okay, 2 projectiles fired from the same point, change with angles. Okay, this is again complementary, right?
Yes, sir.
So it will be same. 11 is 1. Okay, this I already solved.
Yes, sir.
Particle initial motion acceleration. Okay, this is trivial. B equal to u plus 80 for the two components separately.
7√2.
Yeah. 30. It's 5 and 9. So maximum range is the initial projection is how much? Projection angle?
45 degrees.
So in that range formula, you can put theta equal to 45. So sine 2 theta will go. So this you can find, right? U is given. This was a trivial.
It's a 40 meter.
Okay, this I solved. This is also trivial. You have to use the formula for the range and maximum height.
V square sin square theta by
The horizontal range and maximum height are the same. So if we have the formula for two of the things, right? So if you equate them, you get an expression for theta. So from that you can get the value of theta. Okay.
tan inverse 4.
This one option 3 or 4.
4.
Yes. So did you see my videos or not? So while watching the video, you can also increase the speed of the playback speed.
Yes. Do you want me to watch the video before taking the class? Section 1 you told me, sir.
See, you can increase the playback speed. You know this, no?
Yes, sir.
Okay. And also you can skip the video like this by getting the bottom bar.
Yes, sir.
Okay. So because whole thing may not be necessary, because whatever is you understand, you can skip. Right. So if you have any conceptual questions while studying, you write it down on a paper, because you might forget to remember everything. So if you have any conceptual doubts, that also you can ask, and you have to spend more time in solving the problems. Okay. If you're not able to solve the problem, then you can read the corresponding theory. Okay.
Yes, sir.
So spend maximum time in solving problems. Right, and you have to use this link and try to solve all the problems from here. And solutions are given, but just solve without looking at the solution. Okay.
Yes, sir. These problems you have already sent me as PPT. We have solved.
If you want, I can send, but
You already sent it, sir. We have solved it.
no, the problems on this, all of them I will not solve, only few of them I will solve. So what I'm saying is you can solve from here also. Okay, and if time is short, you also solve from the reverse. Okay, 2019 and then 2017 like that. So the LDMs will be a little bit simpler.
Okay.
And if you want more problems, you have to tell me. I can send it.
The problems I have on my PYQ book also.
Okay. Right. Fine. Okay. Any question?
No, sir. So for Wednesday, shall we do more problems in electrostatics, sir? Because we are asking more.
Tomorrow is Tuesday. Monday, Tuesday, Wednesday, I'm class 11. Thursday, Friday, class 12. Up to Saturday. If you want more time on class 12, I can spend more time on class 12. So
No. Equal time.
Sorry? Equal time, is it? Yeah.
Yes, sir.
So Monday, Tuesday, Wednesday, class 11. And then Thursday, Friday, Saturday, class 12. Okay. And right. From next Sunday, I'll give you a test, because you might, if you, I don't know what sort of problems you're solving. If it is too simple, then that's also not good. You have to solve problems at the correct level. Okay. Right. So shall we close now?
Fine. And Thursday, shall we discuss more problems on electrostatics, sir? Because I find it very difficult to see.
Okay. Which chapter? First chapter or second chapter?
First chapter.
First chapter, okay, if you look at PPA, first chapter is basically electric field, no? The only complication will come in using Gauss's law.
Electric, okay, first and second.
Okay, second.
But we have to
second chapter, there are more options of chance of more questions coming out there, because capacitance is there. How to find capacitance or equivalent capacitance, those things. Those things theory also I am not yet finished. Capacitance theory is not yet finished. So I have to do that. And conductors, electric field inside the conductor will be 0. Those things I have not yet discussed. Okay, fine.
But they have more question on charge itself, sir.
Okay, I look at the PYQs. I'll get the idea. So
Okay.
from that I'll see.
Thank you.
Okay, see you tomorrow at 3:30.
Thank you.
Okay, bye.